To go. This is the Boyles law experiment, and the goal of this project is to measure the relationship between the volume of a gas and its pressure when the temperature of the gas is held constant. One, go.
This is a modern version of a classic experiment by Robert Boyle on the compressibility of gases. Boyle discovered the relationship between pressure and volume of gases that now bears his name. This project shows you a simple method for recreating this famous experiment.
This is our recreation of Robert Boyle's original manometer he used in his experiment of the relationship between volume and pressure. Our seal prevents air from escaping our syringe when weighted as the plunger. The string here is to balance the pressure of the syringe and atmospheric pressure.
The plunger is at 30 milliliters of pressure right now. There's a small piece of string stuck inside the syringe to allow air to escape and equalize the pressure with the outside of the syringe. Pulling the string out should keep the pressure balanced.
Now that the pressure is at equilibrium, we are now ready to place the shelf on the plunger to support our weights for each trial.
When we first started our experiment, we started by putting one book onto our plunger with our surface here, and something was wrong with our seal, and it went all the way down. And we could have put it in our bloopers, but we didn't. So we spent a day to look for something to seal it, and we wound up using this right here, and I'll give you a thing. It's a weather stripping adhesive, and it's waterproof. It's what you put on cars. And we're just noting a change to our chemical, our laboratory
Procedure in our laboratory project, we'll be adding weights in even increments by using these nice weights that Mr. Crabtree got us. And the big ones are 2 pounds each. We have 3 of those, and we have 4 1-pound weights that we'll be adding to each trial. And before we add each of the weights, we'll be measuring the volume on each trial and
We have
after.
the volume at 40 milliliters, and now we're adding our 1 pound weight.
Alright, here we go. You had your 1 pound weight.
1 pound weight.
Let's see, let's try shifting it a little bit.
We gotta make sure it's lined up all right, so the force of gravity will go straight down on the plunger. I think you can move the plunger more towards you, Jared. Yeah, right there, about on top. Any note of change?
There's no note of change.
No note of change.
After no note of change, now we are adding a 2 pound weight.
Ready?
2 pound weight. You're pretty center.
Hold on. Blooper.
Yeah, just try it again.
Alright.
Stay in the same video. We had a problem with the weight and the coefficient of friction between the weight and the cardboard. Mr. Crabtree would be proud. We are now placing the weight again and attempting to keep it balanced and seeing a noted change.
We've reset the syringe to 40 milliliters, and now we're adding 3 pounds of weight.
Alright, here goes 2 pounds.
And here's our 3rd pound. Oh, there's a noticeable change. It stopped.
Still went down a little bit more.
Hold on, it's still going down.
Alright, we're still noting changes.
I think it stopped.
It is straight up.
No, it's still going down, I see. Let's see.
Right now, what we're doing is we're tapping just to see if there's any like congestion in the syringe that would alter it.
Okay, it looks like it
Done.
stopped moving.
We have reset the syringe again to 40 milliliters, and now we are adding 4 pounds of weight.
Alright, we could try adding it on at the same time. Let's go. Big noticeable change. Still going down.
Alright, it's
Still going.
Still going.
alright. It stopped. So let's take the weights off and observe from there.
Hold on.
Give it
I
a
think
few
it's still
seconds. Still going.
Still going. Just tapping to make sure.
What he's doing is he's tapping again, and we have a large and noticeable change this time. And I think it's about done.
No.
Alright, we'll give it 10 seconds to see if it'll drop again.
I've stopped tapping it.
I think it's done.
I'm afraid y'all didn't win the test war this time.
And
I don't.
it's still
We have reset the syringe again to 40 milliliters, and we're now adding our last weights, which was 5 pounds.
Alright, I'm predicting this is going to go all the way down to the bottom.
Yeah, I second that notion.
Alright, add on that last one.
So
Yeah, pull up, you gotta pull up, because once I let go, it's gonna try to slap.
Alright.
It kind of balance itself. We have balance. You're pretty straight on. And the
It takes a while to go down.
Yeah, as you've seen in the previous interval, the last one took a while to get to where it stopped. And you can see that we've already dropped 30. Syringe is straight.
Oh, there we go.
8 milliliter drop.
There's another. Wow.
Oh, weights
It's
sliding
sliding
off.
It's hard to keep this balanced.
Let's push the weights
Push them together.
Alright, there you
more
go.
this way. Here, keep the syringe straight. You're leaning.
It's almost at the bottom.
We were farther down than our last one.
It's still going.
I don't know if you can hear it, but you can hear it straining. There's obviously some friction between the plunger and the syringe, the black piece you're looking at, and we have reached the bottom.
Alright, so there are 3 prominent experimental errors that we found. So the first one would be the sealing. We're not sure if air was escaping a lot while we were doing this experiment. The second experimental error was our shelf. It was really hard to keep balanced, as you could see. As we were putting on our weights, we would have to hold it up or else it would tilt slightly, and we would have to hold our syringe in place because it wasn't properly secured. And lastly, our third experimental error was because we have this cardboard on, the friction from the weights makes it easy to slide off, so it's even harder to keep the balance. And the friction from the black plunger you see and the outside of the syringe sometimes kept it congested, so you would have to, that was the reason why we were tapping on the shelf to get it to move past the friction. Alright, so we finished all 3 of our trials, and for the last 2 trials we got varied results from the first trial because we were trying to eliminate the experimental error from our procedure.
And these are our results. As you can see, right here, that's just our measured pressure. If you can get through the glare, that's our measured pressure. We didn't repeat it for each individual thing. I'm sorry about this glare. And that's just for each pound, and that's the same for the whole thing. And that's our results for the second trial, and that's our results for the third trial.